All right. So law of sines and law of cosines. Here's the main thing to remember. Whenever you have a triangle, whenever you have a side across from an angle that you know, you can use the law of sines.
Okay.
But if you don't have that situation, you can't use the law of sines. You have to use the law of cosines or something else.
Wait, what are you saying that rule is? Again?
So if you're given side, angle, side, or side, then you have to use the law of cosines.
Okay.
And if you're given angle side or side angle side, or what else? I think that's it. Then it's law of sines. Because in order to use the law of sines, you have to have a side across from an angle, or else you can't set up that proportion, right? The law of sines says the sine of A over A equals the sine of B over B. It's a very simple formula. But if you don't have a side across from an angle, you can't use it, right?
Yeah.
If you only have three sides, well, you don't have any of the angles, you can't use this, right? Nope. Or if you have an angle between two sides, that means you don't have the side across from the angle, right?
Yeah.
Like this. If you're given this angle and this side, then you can't use the law of sines because you don't have an angle across from the side to use.
Okay. Yeah, because of SOHCAHTOA, right?
Not really because of SOHCAHTOA. You just can't. Like if you're given 25, and if you're given 6, and if you're given 10, well, those are great numbers, but you can't use this law of sines property because you don't have 25 isn't across from the side that you know.
Okay.
So you know what I'm saying? So you just can't use that.
Yeah.
You can't use the law of sines. So you have to use a different method, and that's called law of cosines. And law of cosines says something like c squared equals a squared plus b squared minus 2ab cosine c, or something like that. Did I get that right?
I'm not sure. I'm looking through right now because the thing is I took notes and it was a lot and I kind of got lost in my own notes, and I wasn't here yesterday yesterday we're learning the law of cosines. Before that we were just doing law of sines and stuff, and I'm honestly just lost, like from the start of this week, from the start of this unit. So
yeah, I have it correct. I remembered it correctly. Okay. That's the law of cosines, and this other one is the law of sines. Now you can write this differently. You can solve this for C if you wanted to.
Okay.
Like if you're looking for the side, if you're given 3 sides, then you would want to write it slightly differently. You'd want to write, in fact, I'll even do it. I'll solve it for you. C squared minus a squared minus b squared. See how I'm moving everything over? See how I move this over and this over? And then I'm going to divide by this. So divided by negative 2ab. And then I'm going to take the cosine inverse to get rid of the cosine. So it would be cosine inverse of that whole mess equals C.
Okay.
So that's the other way you can write it. So watch how simple it is to, well, maybe not simple, but watch how you would use this. If I gave you, I'm just going to give you a triangle, and I'm going to ask you to solve it. If I said this is 25 degrees, and this side is 4, and this side is 6, then tell me what the other side is.
Isn't that Pythagorean theorem?
Nope, because it's not Pythagorean theorem, because this isn't a right triangle. You can't use a Pythagorean theorem without a right triangle.
So in this case, I'm going to have to use.
So these, by the way, I'm glad you said that.
Angle, right?
these are oblique triangles.
Yeah, we
Which
learned about
means-
that. Yeah.
Yeah, oblique means they're not right triangles.
Okay.
Okay. You can't assume a right triangle. When I show you this, you can't assume that it's a right triangle. So to solve it, you're going to have to use law of cosines, right? Because you've got side, angle, side, right?
Yep.
So I'm going to plug in the values for this. And by the way, look what I could also do. See, I could just take the square root of that whole thing to get c by itself.
Yeah.
So I'm going to do that too. There's your formula. So what does this c equal? Well, that c equals the square root of a squared, let's call that 4, plus b squared, let's call that 6, minus 2ab cosine of c.
So would it matter if you place 4, like if you place 4 first or 6 first? Because like does it matter where the B, A,
You tell
and C
me.
are on
You
a triangle?
tell me. Does it matter if I switch these?
Oh no. But
It doesn't.
Okay.
Good. It doesn't matter.
Okay.
So ready? I'm going to plug it in. Let's see how we get this to work out. So it's 4 squared plus 6 squared minus 2 times 4 times 6 times cosine of 25. And let's make sure that I'm in degrees. Nope, I'm in radians. Make sure your calculator's in degrees before you hit enter.
Okay.
And hit enter. And there you go. It is approximately 2.915. Now,
Okay. I'm a little bit sorry.
Go ahead.
So it was C equals A squared plus B squared minus 2AB cosine C. That was the original rule, right?
Well, the square root of, c squared was equal to that. So I just took the square root of both sides to give you the formula in a cleaner way.
Okay. But what about the whole inverse thing? That's what I'm a little bit confused on. Like, why does that come into play?
This one right here?
Yeah.
All right. Well, I didn't use, what was I trying to solve for, an angle or a side?
You're trying to find a side.
Yeah, I was trying to find a side. So now that I have that side, I could use that side into this to solve for the angle if I wanted to. So now if I want to solve for this angle right here, I could use the law of cosines if I wanted to. Now, what else could I use besides the law of cosines? Now that I have this side, what else could I use?
You could use
What other method do you know to solve oblique triangles?
law of sines.
Law of sines. So now I could use the law of sines. Watch, I'm gonna use the law of sines to solve now for this other angle. Let's call this other angle. Let's call this angle A right here. Okay.
Okay.
So the sine of A all over 4. Why did I choose 4?
Because that is the side that would be A in this case.
It's the side. That's right. It's the side across from it. Yep. Got it?
Yep.
The sine of A over 4 equals the sine of B. What should B be?
25.
25. Good. Divided by what should little b be? The number.
2.195. 2.915.
Perfect. You got it. So there's my equation. You ready? So we're gonna to solve for this, to solve for A, I'm gonna take the sine inverse of 4 times the sine of 25 all over 2.915. Do you see how I got that? I kind of did 2 steps at once. I first multiplied the 4 over. That's how that got there. And then
I'm just
how do you
confused
undo
on the inverse.
sine? Yeah, how do you undo sine?
Inverse.
Yeah, I do sine inverse. That's right. So that's what I did here. So I'm taking the sine inverse of this. Okay. So the sine inverse
Okay, so you
of um 4. I'm going to be careful here. I'm going to put parentheses. 4 times sine of 25. That's all in the numerator. So I put another parentheses there, divided by the denominator, which was 2.915. And my answer is is approximately 35.45 degrees.
okay.
Got it?
I'm just confused. I'm just still confused on why you're inversing. Is that something that's always gonna happen? Because what I would have thought, shouldn't it be 4 sine 25 over sine A 2.915?
No, because I'm trying to solve for A. So I don't want to divide by this whole thing. I want to get rid of the 4. I'm multiplying the 4 over here, which multiplies on the top, right?
Yeah.
Okay. And then how do I get rid of sine? I want to get A by itself. What's the opposite of
By
doing the
doing the
sine?
inverse.
So
Okay.
I'm taking the sine inverse of this entire expression now.
So is that the same thing you were doing in the previous one? You were trying to get rid of the cosine, right?
Yeah. So for this, I just showed you how to solve. There's 2 different ways you can write the law of cosines. If you're trying to solve for a side, you write it like this. If you're trying to solve for an angle, you write it like this.
Oh, so that's
So
just
this
2
is,
different ways to write it. Okay.
yeah, solve for a side.
So that's just 2 different ways to write it. It's the same law. It's just
Yep,
2 different. It's so it's easier.
exactly.
Okay.
So watch, I'm going to use this to solve for this. Notice I don't have to, but I can, right? So I'm going to try to solve for A. A equals the cosine inverse of, now it's going to be A, right? It's going to be A. The letters are kind of mixed around, right? So since I'm
Yeah.
solving for A, this is going to be A and these are going to be B and C. Get what I'm saying?
Yeah. Yeah.
So this is A squared is going to be 4 squared minus 6 squared minus 2.915 squared. Do you see how I'm setting this up? All divided
Yeah.
by -2 times
And
6
in this
times
case,
2.915.
in this case, doesn't matter which one's A, which one's B, and which one's C. It does, right?
It still does not matter. What the only one that matters is that you're putting these are related to each other.
Okay.
So since I'm trying to solve for A, this has to be my A. These could have been mixed around. It doesn't matter because you'll still get the same answer.
Okay.
Because you're subtracting both of them up here and you're multiplying them both down here. It doesn't matter.
Okay.
So watch, if we did this right, it should be the same answer, 35 point something, right? So cosine inverse, I'm going to do this carefully. 4 squared minus 6 squared minus 2.915 squared. So that's my numerator. Divided by, and in my denominator, I'm going to again put parentheses to make sure that I do this right. It's going to be I'm going to be super crazy with my parentheses. -2 times 6 times 2.915 parenthesis. So that's in my denominator, and hit enter. How about that? It's the exact same answer.
Okay. I'm just a little confused
That's because I did it right.
I'm just a little confused because if C is 2.915 and you're using that one, why is 2.915 in the B position? Like, why is it -2, 6, 2.915? I thought 2.915 was C. That's why I'm.
Remember, this C is only relating to A, B, and C are just they're subjective or they're objective. It depends on what you're looking for. I called this A because originally I called this C when I was first solving for this. Remember?
Yeah.
So I'm really not solving for C. I'm solving for A. So I could rewrite this if you want. I could rewrite this as A and this as C.
So it's gonna work either way.
This is A. Yeah, just make sure you're clear with the fact that whatever your angle is that you're solving for, that is the only place that you put the side. See that angle and that go together.
Yeah.
So what was I trying to solve for? I was trying to solve for A. So 4 goes here, and these other two numbers go here and here. Okay.
Okay.
If you go back and watch it, you'll understand, I think. So try to find a problem now that we can do some more problems from your homework so that I know, because you might be doing other stuff too, like navigation problems or things like that.
I'll get one real quick. These are all just simple law of cosines ones. These are from yesterday. Okay. These are from yesterday. It's from the homework that I missed. This was the homework for today. So these are like just 2 examples.
All right. So which property should I use for this first one?
Well, law of cosines, it's gonna be.
That's right. I have side angle side, right?
Side angle side, yeah.
So it's going to be, so notice that I have A. So notice in this formula, see how in this formula I have C. So I have to rewrite this formula. If it's confusing for you with the letters, just rewrite it as A. Okay. So here's how you rewrite it. A equals the square root of B squared plus C squared minus 2BC cosine of A. See how I rewrote it? I changed the letters.
Yeah.
So that I wasn't confused. I would suggest just doing that. It's always going to be whatever you have here is the angle you're looking for. And these are the other ones, and you're adding the squares. And then you subtract double the product of these other ones. And you multiply that by the cosine. So now if I plug it all in, It's just the square root of 30 squared, doesn't matter if it's 30 or 21, doesn't matter, plus 21 squared minus 2 times 30 times 21, whoops, 21 times the
Could
cosine
we
of
still have done it the way where it
123.
would just be C equals? We still could have, right?
You could have, but you're gonna maybe get confused with the A, B, and C with the letters.
Okay,
So
but
to avoid
no,
that confusion,
I'm
I wrote
I'm
it
a
like
little
that.
confused how you flipped it around to that A equals, how you flipped it around so quick, like differently, because you said the letters are just like
It could be the law of cosines can be, you can put whatever letters you want in here.
okay.
If you wanted to write it like, if you wanted to make this A, just write A. And then instead of A squared, it's going to be B squared plus C squared, right? Minus 2BC times the cosine of A,
Yeah.
because this is going to be related to this.
Yeah.
Or if you want to write it for,
I see.
if you want to write it for B, you just write B equals A squared plus C squared minus 2AC
Cosine
cosine of
B.
B. Yep.
Okay, so it has to be consistent.
It doesn't matter
Okay.
what you write A, B, and C. Just make sure that your angle and your letter are there and there. You got what I'm saying?
Yeah, I do.
And same with this other one right here.
Okay.
So there's the law of cosines written in a different way. Same with this. You could write this in a different way if you wanted to. You could write it for A and for A or for B, and just this goes with this.
Wait, but you couldn't do like B equals B squared. You couldn't do like B equals
if you wanted to solve for angle B, it would be the cosine inverse of B squared minus A squared minus C squared all over -2 AC instead of AB.
Okay.
Because
Okay.
these have to be the same.
Yeah, I see.
Because these are coming from here.
Yeah, but you couldn't do, for example, minus 2AB in the denominator, right? You can't do that.
Correct.
That's okay.
No, because
No, I
because
see.
that has to be there. Yep.
Has to be consistent.
Just
okay.
yes.
Okay.
Just be careful with just be careful with the letters you have there. So this is A here. So if I just take my calculator and I punch it in, and by the way, let me show you another little trick here. You could store values in for A and B if you wanted to. So have you ever tried this before? Like I could do 30 and I could hit the store button. You see the store button right here?
Yeah.
STO 30 store, and then you can hit alpha and then get your letter. I'm going to store that for B and hit enter. And then I could type in 21 store alpha C and hit enter. So now if I wanted to, I could, and then by the way, A, I would store 123 for A. 123 store for A. Now, this might seem like too much work for you, and I understand that, but you'll see why it's a shortcut. And then you can just type in your formula. Square root of whoops. I'm going to type in, it's going to be B, right? It's going to be B.
So it's going to be 30 squared.
It's going to be B squared plus C. You'll see why I go through the trouble to do this in just a second. Minus 2 B C cosine A, and hit enter, and it's going to give you that answer. Now you might say, well, I wasted so much time doing that. Well, no, now you have this formula. Now that you have this formula in, if you want to change the letters, if you want to change it, let's go back to the previous page.
Okay.
Now all you have to do is store the different numbers in here. Now I'm going to store 4 for B. Watch, I'm going to do this one right here. I'm going to store 4 and 6 and 25. for B, C, and A.
Oh, so
Watch
now
it.
you no longer have to actually like change it, the formula.
Yeah.
You know,
Yep.
you just
Exactly.
store it. Okay.
Yep. You got it. You got it. So 4 store, and you get quicker at doing this if you want to do this. 4 store B, 6 store C, and 25 store A. And now all I have to do is watch. I hit second, enter, second, enter, second, enter, second, enter, and it gives me that formula back. It toggles you back through what you've inputted. And now I hit enter, and it's going to plug those new values of A, B, and C in.
Okay. Okay.
And there's my answer, 2.19915.
Okay.
You see what I'm saying?
Yeah.
So in a way, you can kind of program your calculator if you wanted to, and it just makes your life a lot easier. Hold
Okay.
on.
But you can
Stick around, Gabriel, because Mitchell's coming in. I'm sure he's going to be asking the same questions. What's up, Mitchell?
Hey, Mr. Dwyer, how you doing?
Good. Gabriel's here with us too.
Oh, hey,
Are you
Gabe.
doing law of sines and
What's up?
cosines?
Yes, I am.
Perfect. So he's probably just going to stick around and listen in on yours. But let me go over, Mitchell, with you what I just went over with Gabriel. Okay.
Okay.
And this is on his Jamboard. And if you guys want to share them with each other, you're welcome
Yeah.
to. But
Sure.
Yeah.
here's the law of cosines. These are for oblique triangles, right?
Yeah.
When you're solving oblique triangles, which means not right triangles, you have either the law of cosines or the law of sines that you can use. The law of cosines is used when you have side, angle, side, like this right here, because you can't use the law of sines to solve this because you don't have a side across from an angle yet. So you have to use the law of sines, right?
Yeah.
Or if you're given 3 sides, which we haven't done yet, but we're about to. Look at this problem. See what this one has?
Yeah.
It has
Yeah.
3 sides, right? So you can't use the law of sines because you don't have an angle. For the law of sines, for the law of sines, you need to have an angle in order to use the law of sines. You need to have an angle across from a side. So if you have side, angle, side like this, you don't have a side across from an angle yet. Or if you have side, 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 like the one I just showed you on page 2, you don't have an angle yet. So you can't use the law of sines, but you can use the law of cosines. And notice I've written it 3 different ways here. Solving for C or for A or for B.
Okay.
And then I've also rewritten it for angle C or angle B. And I could also do angle A if I wanted to. A would equal cosine inverse of A squared minus B squared minus C squared all over negative 2BC.
Okay.
Okay. That's your law of cosines. Here, let me make a big box for this so you don't think that that's the law of sines. That's the law of cosines right there. 6 different ways you can write the law of cosines.
Oh, wow.
Okay. You're going to write it like this when you're trying to solve it for a side. And you're going to write it like this or this or this when you're trying to solve it for an angle. Make sense?
Yeah.
Yep.
Okay. So here we go. We're going to solve it for an angle. You ready? And also, Mitchell, I was showing Gabe how nice it is to use your calculator and to use the store button if you have to do a lot of these problems.
Oh, yeah.
Because then all you do is you store. See how I use the store button here? See how I store A, B, and C, and I just toggle back and get this equation back and hit enter. You could also do it that way.
Wait, how do you store A, B, and C?
Whoops. So you type a number in. Here, let me make up a new problem. Let's say that I have the triangle. I've got 10 and 15, and I've got an angle of 20 degrees. You type in 10, you hit the store button, and then you hit alpha and type in the letter.
Oh, that's cool.
I'm actually using B and C for my sides, and I'm using A for my angle.
Oh,
Okay.
that's really cool.
So 15, store, alpha. Now your alpha looks a little different. You have to like hit alpha, and then you have to find.
Yeah, apps is
for-
B, draw, like,
Yeah.
C,
Yeah,
like,
you,
yeah, I
you
see what
kind
you're
of have to
saying.
see what I mean. So it's slightly different than this digital one, this iPad app calculator. And then
Yeah,
I'm going to
actually,
store 20 for A. And now all I have to do is toggle back up here and hit enter. Whoops. No, I don't. I have to go all the way up here because I accidentally did it too many times. Hit enter, and there's my formula plugged in, and hit enter, and boom, there's my answer.
oh, wow.
6.
Is there is there a way
56.
to like save these equations in your calculator?
I mean, it's always going to be on your screen. Yes, there probably is a way to save it. You can actually write a function for it, to be honest. If you Google it, like how to write a function for law of cosines in your calculator, and it will work. The problem is, like if you're going to ACT or SAT or even some math teachers, they'll make you clear your memory and it'll delete that whole thing out for you. But you can
Gotcha.
actually write a whole program. See this program button? You can write a program for, in fact, it might even be in here. Law of cosines, law of sines. Let's see. This has a quadratic formula in here, but it doesn't have law of cosines or law of sines.
Okay.
But you could create one. And I'm not
Cool.
going to spend time showing you, but here's the quadratic formula one. When you hit it, enter, it's going to ask you for A, and then B, and then C, and then you hit enter, and boom, it grabs it for you, and it finds the. See that?
Oh, yeah, that's cool. Wow.
So you could create you could write basically a formula. It's just computer code. You could write a formula for the law of cosines, but essentially that's what you're doing when you type this in, and when you do the store, when you use the store button. Okay.
Okay.
So let's figure out this one here. So I've got 6, 9, and 14. So to find angles, so here's my law of cosines. It's going to be a squared. Remember, it's a squared equals b squared plus c squared minus 2bc cosine a, right? So,
Yeah.
so A, if I'm trying to solve for A, I'll show you how I did this. Gabriel, watch this again.
Yep.
To solve for A, I'm going to basically subtract everything out. So subtract the b squared out, subtract the c squared out, divide by the negative 2bc, and then take the cosine inverse of that entire thing, and that's going to give me my A. And the only thing I have to do is I have to switch those different letters depending on what I'm trying to get. I always want to make sure that this and this, if I'm solving for A, if I'm solving for this right here, this is my A, because whatever's across from it is your A. Don't look at A, B, and C. Look at what's across from the letter you're trying to solve for. Make sense?
Yeah.
Okay, so watch. I'm going to use my formula now to do this. Watch how cool this is. I'm going to clear everything out. So I'm going to just go ahead and type in, I'm going to store 9, 6, and 14. So 6, I'm storing for A. 9, I'm storing for B. And 14, I'm storing for C. Now those are all side lengths, right? Now I'm going to type in, so what did I just find there? I'm finding 6. So so this is the one I'm trying to find, right? So I'm going to call it A. I know this says C, but I'm imagining that this is my A right here. Got it? So I'm literally going to just plug this straight in. I'm gonna plug this straight in. So it's the cosine inverse, and I have to be careful. I'm gonna use parentheses here. It's gonna be a squared minus b squared minus c squared. And now I put parentheses around it. You see why I did that?
Yeah.
It's like I'm making sure that that's all in the numerator. Got it?
Yep.
And I'm going to divide that by, and I'm going to be super psycho about this too. I'm going to put -2 in parentheses times b. I don't really probably need to put the times, but I'm going to do it, times c. And then I'm going to close that parentheses off. See, have I closed all of them off? This is like a computer programming thing. Whoops.
I think you still got to close one off for the whole.
Yeah, I think I still have to
function.
close one off. Yeah, see how when I put it there, it shows me what I'm closing off? So now hit enter. And there's my answer.
Dang.
So what did I just solve for?
An angle.
Which angle? A, B, or C on here? A, B, or C?
C.
That's right. I solved for C because 6, right? Gabriel, you get what I'm saying?
Yep.
Okay, so that's C. So that's C. C equals 16.99 degrees. Now, I could now use the law of sines if I wanted to, but since I spent all my time doing this, watch what I'm going to do. I'm just going to switch now A and B. I'm going to make 6B, I'm going to make 9A. So 9 is stored for A now. So I'm solving the one across from the 9. And 6 is stored for B now. And now I just toggle back up. I grab this thing again and I hit enter, and boom. There's the angle across from 9, which is B. 25 point. It's really just 26 because it rounds. 26 degrees. Because if I round that up, it's going to round up to 26, right? And now if I wanted, I could do that same thing to find A, and I'm just going to switch out 14. 14 is going to be my A, and I'm going to make the 9 my C now instead. So 14 is my A, and 9 is going to be my C since I had to replace that. You get what I'm saying?
Yeah.
You all get what I'm doing here?
Mm-hmm.
And hit enter, and it's 137. Now, guess what happens when I add these three things up?
They're going to equal 180.
They better. What's 137
26
plus 26
Should
plus
be it.
17?
Yep. Boom.
About
180.
that. Okay. And that was if you have a graphing calculator, it's really pretty easy to do that. Now, you could have used the law of sines instead if you wanted to. Oh, I just lost my calculator. Hold on. I hate when I do that.
This literally just answered all my questions that I had in like 11 minutes.
There you go. That's what I do, buddy. That's what I do.
Yeah,
All right.
because I'm so confused on that part. Now wow.
Now I just jacked up my calculator. How do I turn that calculator?
You know
back
the
into-
bottom thing? If you hold on that,
Oh,
then close out of the app and then restart it maybe.
Wait, where you
That's a good
had
idea.
A squared equals B squared plus C squared minus 2BC cosine A, that's the same thing as you were showing earlier with just square rooting both sides, right? It's still the same formula. Just making sure.
Okay, say that one more time.
The A squared equals B squared plus C squared minus 2BC. That thing, that's still the same formula, right? As you had on the
Yeah.
other side, just the square rooted version. You could still
That's
type
right.
it in as the square rooted version, right? In the
That's right.
calculator.
See, look
Okay.
at this right here and this.
Yeah.
This one, I square rooted it to get rid of
Mhm.
that. But for the reason I wrote it like this is because I wanted to rewrite it like with the A. I wanted to solve for the A.
Okay.
So I was showing Mitchell how I did that, or how to do that.
Okay.
It's really weird that your calculator.
Oh, there we go. There we go. I couldn't remember how. Oh man. Now it's hiding over there. Multiple
Oh,
windows not
split
supported.
screen it.
Yeah, I'm trying to split screen it. I can't remember how to do that.
Yeah, it's the 3 little dots at the top.
Okay. So if I click this and I click that, what do I do? There we go.
There we go. Yeah.
But see, that didn't quite work right. It's not like hiding it correctly. I don't want it actually split screen. I want it to be hidden. How do I make it hidden?
That I don't know.
Where's Sarah when I need her? See, it's there and I can't.
What if you were to, you see the one on the very right? Does that hide it?
You'd think it would because it's doing the same thing as the split screen, but I think that's supposed to hide it.
Yeah, maybe if you try.
Oh, there we go. I guess I needed to have the app open for it to hide it. Yeah, that worked. Okay. You guys, you have more questions for me? Let's do some more problems.
All right. I shared a Jamboard with you, so I'll just copy and paste quickly.
Okay, sounds good.
Um,
Gabriel, you practicing some more?
Yeah, I don't know if I should add more questions though, because it's technically Mitch's session.
Yeah,
so
just watch. Yeah, just
I'm
watch
just
it,
trying to
honestly.
listen, you know. Not
what's your email, Gabriel?
Gabriel STA7382 at
All right.
K12.
Okay, so what am I going to
That
use
IP
for
is
this
gonna work.
one?
For the first one,
Yeah, what can I use?
that's angle, side.
Right.
So would you use the is that a sign
Well,
actually?
you could use the law of sines, but what do you have to find first?
You have to find another angle.
That's right. And is that hard to do?
Yes.
It is not. How do I
Oh.
find this angle if I have two?
Let's see. You have
Gabriel, if I have two angles, how do I find the third one?
Two angles. The third one, a law of sines.
Nope.
Angle,
They
angle,
all have
side.
to add up. No, they all don't forget what the basic stuff. What do three angles always have to add up to?
180.
Oh, 180.
Yeah. So just subtract it from 180.
Oh.
So that's 40. Now that I have that, what can I use?
No, you can use
Uh, I have a side and an angle across from it. What can I use?
oh, you can use side angle side.
No,
Actually, no,
I
you
can
can use angle side.
Well, which one? Law of sines or law of cosines?
Law of sines.
That's right. That's what I was looking for. So the law
So
of
that's sine
sines says
A over A
the sine of
equals sine B
40
over.
divided by 24 equals the sine of, let's say, 22 divided by b, whoops, lowercase b, which is over here. You get that?
Right. Yeah.
So that means I'm gonna cross multiply. So that means that this 24 times the sine of 22 equals b times the sine of 40. And this is just a number, right? So I'm going to divide by that. Y'all get how I did that?
Yeah.
So b equals that. So let's type that in. 24 sine of 22, make sure your calculator's in the right units, which it is, divided by the sine of 40. And there's my answer. B equals 13.99.
Yep. Got that.
Got it, Gabriel?
Yep.
All right. And then how could I find C? This, or A rather, A. How could I find A?
Let's see.
Well,
You can do.
Side A.
Oh, so you have side B now. So could you
you have
could you
two
just
sides
switch it
now.
up?
Yep. What should I do? Tell me what to do, guys.
Oh,
Should
you could
should you use law of is it better to use law of cosines in this case, or is it still easier to use
No,
sines?
law of sines is usually the easiest. Unless you have it programmed in your calculator, then the law of cosines is pretty easy too.
Okay, so you could use side angle side.
Yeah, let's use the law of sines again. Ready? The sine of 40, I'm setting up this exact same way. Divided by 24 equals, now it's going to be the sine of what?
22.
40, 24, 22.
Sine of 118,
Oh, because that's across from the B that we're solving
right?
for.
Divided by A. Now watch this, you guys. Isn't the only thing that's different the fact that this is 22 and that was 118? Isn't that the only thing that's different?
Yeah.
Do you see these formulas? Do you see how these two formulas look the exact same? The law of sines. So why don't I just go back to my calculator and type in, unfortunately I didn't all type it in at once, but it's essentially just the same answer. It's just A is going to equal 24 sine of, instead of 22, it's 118 all over the sine of 40. You see how that looks almost the exact same?
Yeah.
It's because it's because it's almost the same formula, except instead of using 22, I used 118. So now I can just take my calculator and type
Is
in
it
essentially the same thing that I just
32.97?
had. In fact, I can just even steal this. There's that, hit enter, and then divide that by, whoops, sorry, I didn't mean to hit enter there. Let's try that again. Let's grab this and let's change that to 118, hit enter, and divide that by the sine of 40. So my answer is 32.97.
Okay, just a quick question. Couldn't you do like when it's sine 118 over A, couldn't you also make that equal to sine of 22 over B? Since we know
You
B,
could have. Yep, you could have.
it would be the same answer, right?
It would. Yep. If you
Okay,
wanted to
just
make
making
this
sure.
sine of 22 over B, you could have done that. But we had already, those were nicer numbers, right? B is not as nice of a number.
Yeah,
See how B is a decimal?
yeah.
Always use as exact numbers as you can if you can help it. So let's use the one that we didn't have to estimate. See how I estimated this? I should have written approximately.
Yeah.
Right? Always try to use the exact ones. All right. How about for number 2? What am I going to use for number 2?
For numeral 2, you have angle side, so you should use law of sines.
Yeah. Anytime you have a side across from an angle, or you can easily get it like we did here, right? Then just use law of sines. So Gabriel, tell me what to write. Sine of what?
Wait, first thing I would do, shouldn't you get the third angle, or do you not need it? Just like right
I don't
away.
need it. I don't. You
Okay.
can.
Okay.
You can. Yeah,
It's
that's easy
83.
enough.
I can.
Yeah, that's easy enough.
I would do sine of 44 over sine over 7.
Sine of 44 over 7 equals what?
Sine of 53 over, we're finding a, okay, yeah, sine of 53 over what would that be in this case? C.
Good. So how do I solve this, Mitchell? What do I write to solve it?
You're gonna do 7 times sine of 53 divided by the sine of 44.
Good. I'd cross multiply, and then like he said, you divide both sides by the sine of 44.
Yeah, I just kind
7
of
sine,
put that all together.
totally fine, totally fine. And that's what I do too. I just don't want to confuse anyone else that might not know that. Okay,
Okay, so now you
Got
got
it?
C equal. Okay, so now you just plug
So-
that into your calculator and get C.
plug and chug. So 7, I'm gonna
Alright, I
do it
got my
all at
answer.
once. 7 sine of 53 divided by sine of 44. And there's your answer. So C is approximately 8.05. And now watch, I'm gonna do the old second enter to get my formula back. And what's the only thing I have to change to
You
solve
need to
for
change.
A?
Let's see. So you're solving for A. So you want to change out the 53 with 83, I believe.
Perfect. Change the 53 to 83. That's all you got to do. And there you go.
This
Make
is
sense?
just so much. Yeah, it's so much easier than it was a few minutes ago.
Gabriel, you see how I did a little switcheroo there?
I see.
All right.
I think I see.
Do you also have a quiz on this on Tuesday then, Gabriel?
Yeah.
Right before the SAT.
Yep. Yeah. Tuesday quiz on this.
All right. So for number 3, what would I do?
For number 3, you have angle, size. You want to use law of sines again. And
So what do I find first?
so you want to find B first.
Angle B.
Yeah.
Yep. So I'm finding angle B.
Oh,
Hey, that's, wait a minute. An oblique triangle?
oh.
Not. So guess what? You don't have to use the law of sines. What can you do when you have a right triangle?
You can do the
For a right
formula.
triangle, you can do 2 things. You can use Pythagorean's theorem, or you can use SOHCAHTOA.
Oh,
So for you don't need the law of sines. You can use the law of sines or the law of cosines, but you don't have to. All you really need to find the other sides is SOHCAHTOA. So the sine of 39, what's the sine equal to?
sine of 39 equals.
Sine is what? What's OH mean?
Oh, opposite over hypotenuse.
It's the opposite, which would be A, right? A divided by the hypotenuse, which is 27.
Oh, okay.
Got it?
Yeah, so you're gonna want to do 29 times the sine of 39. I mean 27 times the sine of 39.
Gabriel, do
And
you see
that's
how
gonna-
that worked?
Then it's gonna give you 17 rounded.
I'm a little confused. Oh, it's SOHCAHTOA. Oh yeah, because it's a right
See,
one.
Yeah, because we found that B was at 90 degrees, that means this is a right triangle. And now you don't need to use the law of sines and cosines. You can, it still
You just use
works,
SOHCAHTOA.
but you could also just use SOHCAHTOA, and that's probably easier.
So opposite over hypotenuse. So then you get. Oh yeah. Also, what I wanted to say with SOHCAHTOA, the only thing that confuses me, I realize that sometimes I mix the I get confused between the adjacent and the opposite, which is like a big problem. But I realize that's something that I do sometimes.
The adjacent of this one is the opposite of this one. So adjacent and opposite, it just depends on which angle you're looking at. If I'm looking at the 39-degree angle, the 39 angle, the opposite is A, and the adjacent is B. But if I'm looking at the 51, the opposite is B, and the adjacent is A. So it
Yeah.
depends on which one you're looking at.
Okay.
Okay. So that's all
Okay.
you had to do for that one.
Okay.
Yeah.
Oh, and then, by the way,
Oh, we
that's
also
what they
gotta find
wanted.
C.
They wanted you to find BC. So that's what we found. Right.
Yep.
So I didn't really read the directions, but that's all we needed. Okay.
We
How
just
about
need
for
to
this?
find
They
A.
want us to find B, which is really letter C, right?
Yeah.
So how do I find that if I have,
You have angle, sides. You can use law of sines again.
okay, so
This
what do I
one?
find first?
First you want to find the third one. This is 180 minus 101 minus 63. What you got, which is 16.
There's
So you're
16
gonna
degrees. Now
do-
what?
You're gonna do, I believe it's gonna be sine of 16
Sine of 16 over
9
9 equals,
equals sine of, I believe this one's 101, I want to say.
no, what are we trying to find?
C. Oh, C. So you need 63.
Do you get that?
Yeah.
Gabriel, if I'm trying to find C, I want to get, you would use the one across from it. Get it?
Yeah.
So
Yeah.
sine of 63 all over C, and now cross multiply. C times the sine of 16 equals 9 sine of 63, and now divide by the sine of 16. And by the way, you can't just divide 16 and 63, right? You got to use the sine function, right? So
Yeah.
carefully plunge in 9 sine of 60. And by the way, if you want to just go up here and steal this one, see how I just went up there and I stole that? Whoops. Never mind, I can't steal it because I just cleared it. Dang it. If you had already typed it in, you might as well just use it. You might as well just steal it and use it again. 9 sine 63 divided by sine 16,
That's what I got.
29.09 approximately. Good? You guys feeling better about this?
Yeah, I
A
am.
lot better actually.
Awesome. All right. Well, hey, good luck this week, and I'll see you probably next week.
Yeah, thank you. Thank you so much for the help.
I got
I feel like I
Sunday
got it
scheduled
now.
with you.
Yeah, no problem. You guys, as always, you can watch the video again if you want to just
Yep.